So you've built a couple of agents and you've deployed them, you've done a demo, and it just does not cut it. It is not working. It is giving you challenges. It is giving you problems when you actually try to push this into production. In this video, we're going to take a look at 15 different areas you have to consider and think about when you are trying to design, build, deploy, and maintain these AI agents in production. So I'm going to talk about why each particular aspect is important and why you have to pay attention to each part. So let's get started. In order of consideration, we'll start with the user experience. This is a very important aspect that cannot be ignored, and this is the most important part. So we'll start with the user experience. Then we'll talk about governance, risk, and compliance. Then that will feed into security, identity, and privacy. And then we'll talk about different things you have to consider when designing for human in the loop and escalation. And then we'll talk about why the data quality and the data pipeline that creates those data sets are important for your AI agents to be successful. We'll briefly go into context engineering and how to retrieve the data that the AI agents need to solve the problem you are giving it as a task. We'll talk about tool calling architecture and the safety considerations that you have to consider, and the memory design and how to manage state. Now we're going to move into what you need to think about when you are picking your large language models and how you are routing different tasks to different models within the different agents if you have one or more agents. There are some scenarios where you may have to break down a particular task for multiple agents to handle. So we'll talk about multi-agent collaboration and how to orchestrate that. And then there are scenarios where you would have to think about what the agent is about to present to the user before giving that to the user. So that we'll talk about reflection, validation, and then how you can also evaluate these language models and these agents against benchmarks that you have set for your particular use case to consider. Then observability, diagnostics, and tracing will be another thing that we'll cover. And then there are scenarios where you have to try to balance the cost of running these operations against the pricing structure that you are having. So taking a look at the performance and how to optimize that, taking a look at the cost structure and what is factoring into those costs is also very important. Reliability, resilience, and how to handle errors and problems is also important. And then we'll cover how to deploy and some of the CI/CD pipelines you have to set up to make sure that your your agents can be maintained effectively in production, and how to manage the life cycle. So these are some of the things we're going to be talking about. And the next thing we're going to consider now is why each of these is important. So because of the dependency between the different aspects, I'm going to briefly talk about why it is important. So the user need feeds into the risk boundaries you have to consider. So if we're doing something for a healthcare customer, that's very different from a retail customer where the level of privacy is not really significant and some of the things you have to think about is not really the same. So the user experience and why you're creating this agent is very important for us to consider the risk boundary. And that also fits into the security model and how the agentic structure and the infrastructure that you're going to need to make this run. And if you need to do multi-agent collaboration, how do you authenticate, and all those different things have to be considered. Then this now feeds into the human control points. And then once this is considered, then we take a look at the data structure, the data quality, the data pipeline, and what it takes to make that happen. Once the data pipeline is now fully set up, then we need to take a look at the context strategy that we need for the agent. So depending on what you're trying to solve for, you have to manage context differently to support going back to the user experience. Different capabilities that the agents need to do their work, to bring in data, makes you have to focus on the tools that are needed to provide it with the capability to retrieve data and take action. And then This now fits into how you do state memory and state management. The large language model choice that we use is going to be critical to power the different use cases. If you're doing voice, you may need a different set of language models for that, depending on whether you're doing speech to speech or you are setting a pipeline to convert the audio to text and then route it to a text-only language model and then use another model to convert the response from text to voice and audio again. So different scenarios requires you to have different considerations for different large language models. And then in scenarios where one agent alone cannot handle the work, we have to see how we can break up the task and how we can bring in orchestrator agents to partner with specialist agents to get the job done through multi-agent collaboration. And then we'll have to evaluate and see how everything is going. Obviously, we have to keep track of what is happening so that we can debug, even though it's very challenging for us to debug and monitor these stochastic systems that are probabilistic in nature. So observability is another thing we have to consider. And then once you are able to monitor everything, you can now figure out what is not working, and then you optimize, and then definitely resilience is something we have to consider. And then pushing this to production is the next step, which is the final thing we have to take a look. So if you really think about the 15 things we briefly covered, you can see how each one fits into the next and so on. So let's take a look at a simpler way that we can say this. First, we need to define what is it that the agent is trying to do. This is the most important question we have to consider. If you just want to jump into using cool terminologies like MCP, like A2A, or the latest large language model that has just landed, then you are making a mistake doing that. The most important thing and what really drives the A2A, the MCP, the model choice, and all those different frameworks that you might even think about considering is the user experience. If you're doing a text-only agent or a text-only scenario, then that kind of takes a look at and determines what tools you need. If you even need to do agent-to-agent collaboration, if you need to use a language model that has low reasoning abilities or a large language model that requires very high reasoning abilities and powers. So the user experience is where everything depends on. This is what you have to think about first. Spend more time thinking about the user experience and all these considerations and what the agent should and should not do before you even think about anything else. And once that is done, then we need to define and set constraint boundaries as to what the agent is going to be allowed to do and not allowed to do. So user experience determines what we allow the agent to do or not do. And once that is figured out, then we can now think about whether this will be a single agent scenario or whether this will be a multi-agent scenario. In such cases, do we need to even set up MCP servers, or we can just set up functions that are one time only and everything will be done there? But when you have multi-agent scenarios, you may have to build your tools in one place and then use model context protocol to share those tools across all the different agents that you need to run. And definitely, if you have more than one agent, you may have to consider all these orchestration patterns and agent collaboration protocols. Some of the protocols that you may have to consider and some of the strategies would depend on whether the agent is going to be in the same physical process or across multiple processes. So if it's in the same physical process, then you can use the workflows that are available in frameworks like Pydantic, LangGraph, or Microsoft Agent Framework. So that is when it's in the same system process or same computer. When you have it across multiple processes that are independent, then you have to consider the agent-to-agent protocol in order to make this happen. So again, everything starts with the user experience. The user experience tells us what we need the agent to do and not do, and this is going to determine what tools we need, what actions the agent needs to take. And depending on how sophisticated or how simple the task is, you may or may not need multi-agent collaboration, whether it's in the same process or across the network using the agent-to-agent protocol. So you see how all of these are tying together. And then once we have that, then we can now evaluate for optimization and how to make it run in production in a way that is sustained, and we can monitor and maintain it effectively. So that is what I'm trying to say by calling out all the 15 different points that we are going to discuss in detail in the video. So these are all the points we're going to be talking about, and let's start with the user experience. So as I was saying in the intro, the user experience is very, very important. This is what you have to think about whenever you're designing any AI agent. So don't start with MCP, don't start with A2A. Really think about what do you really want your agent to solve? What challenge and what problem and what user experience are you trying to create by designing this agent? Because if you don't really have these requirements clearly defined, then you're going to completely miss the point and create something that will not really have any value once you've spent all the time, the tokens, the financial resources, and everything you have to design the system and the software. So start with the user experience, find out what problem you're trying to solve, what the outcome is, how you're going to interact with the agent. Will it be by text? Would you need to present images as input? Would you need to present voice as input? What is the output response going to be? Are you generating videos? Are you generating images? Are you generating audio, or is it only text? So all of these things are going to impact the downstream architecture that is going to be needed to support this experience you're trying to set up. So as you can see, I'm spending a lot of time to cover this because it is important. And if we get this wrong, then everything else is going to be a challenge. So spend more time on the user experience, and you're going to be able to figure out everything else that you need to bring this user experience to life. Once we've figured out the user experience, the next thing is to figure out the boundaries and how we're going to govern this system. So if it's one agent, what are we going to do to make sure that this is running properly? What are the risks we're willing to take? What are the compliance requirements? When you're dealing with healthcare information, when you're dealing with certain customers in Europe and certain sovereign entities, there are certain considerations you have to consider because of the laws and the compliance expectations in those geographical regions. So you have to think about this. Once the user experience is determined, that now governs what compliance we have to pay attention to. So what is going to be high risk, what is going to be a problem, and what can we tolerate. So all of this is dependent on the user experience and the objective that the agent is expected to solve. Once the compliance is determined, we can now think about how to manage identity. This includes how to identify the users that are interacting with the system, how to identify agents, what protocols are needed to properly authenticate the agents in multi-agent collaboration, and to authenticate and keep track of who is interacting with the system. So identity, access control, privacy, isolation of tenants, and the secret management, and all the different permission models, role-based access controls. All of these things you have to consider to make sure that the data that is sent to the system is secure. The person that is trying to access the records have the permissions to read, to modify, and to remove records. All of these things have to be considered whenever you are designing an AI agent system. The next thing we have to think about is the human in the loop and how things are escalated. So where does the agent need to function on its own, and where do you need to make sure that you actually verify and approve what the agent is supposed to do before you move to the next step. So particularly in certain workflows where if you get something wrong in the beginning or at any stage of the sequence, the whole answer or the whole output is going to be invalid. So where do you need the agent to function autonomously, where you are able to tolerate certain outcomes, and where do you really need to step in as a human to take over and confirm before you allow the agent to proceed. So think about these scenarios, and it all ties back to the user experience and the constraints that are going to be governing what you're doing for your agent. So this is something that cannot be ignored or forgotten about. The next thing I want to cover is the data quality and the data pipeline that is needed to provide this quality. So when you're designing your AI agent, think about what is the particular set of data that my agent needs to function to solve the problem. So if you have a real-time system, then you have to make sure that you have the proper pipeline to support that use case and that experience. So again, everything goes back to the user experience. If you have bad data, if you have improper data pipeline, or a data pipeline that cannot sustain what the user experience needs, then the quality of data would be outdated, would be stale, would be filled with errors. And if you don't have the data pipeline correct, if you don't have the right data infrastructure, you're not picking the right data store. If you have to use a document store, you are trying to use something like a relational store. So picking the wrong data store, picking the wrong data pipeline would contribute to poor data quality, and it is going to create a bad user experience. So think about what data set your agent needs to function, where it's going to come from, how fresh it needs to be, and what are the pipelines that are needed to be set in place to transform the data from the original form into the format that the agent needs to function properly. So this is another very important part, tying back to the user experience. Very, very important. Context engineering and retrieval design is very important. Once you have determined what the user experience is going to be, then think about what you need to set up in order to allow the agent to function properly. The goal here is to make sure that you are giving the agent just enough information that it needs to be able to predict and generate the next step in the sequence. So you don't need to dump everything to the agent, just provide it with whatever it needs to answer the question or to perform the action you want it to perform. So the retrieval design is very important, and this is where the data pipeline is also critical. Depending on what you are trying to do, you might need to set up a vector store, a relational store, a key value store, a graph store, an object store. All these different stores are very important in configuring the context and the retrieval strategy that your agent needs in order to be able to perform the task that is assigned. So this is very, very important. In a future video, we're going to do a deep dive into each of these points, where the video will be dedicated to just one aspect of the 15 sections we're considering today in the video. Tool calling architecture and tool safety is very important. Making sure that we have proper descriptions for the tools, making sure that the tools are not too similar, making sure that we're only bringing in the tools that we need to perform the task. There's no need to load all the tools, even though the agent is not really needing it to function. Sometimes, if we have too many tools, we might consider breaking up the agents into a multi-agent scenario where you have a different set of tools assigned to specific sub-agents, so that the agents are not confused or distracted because of all the tools that are present and are not really relevant to the particular task at hand for them to control. So think about what tools you need. Think about how these tools will be authenticated if you're using model context protocol, and how you can set up constraints and throttle how many requests are going to the tools, and you can also audit what is going to happen. The next thing is memory design and how to manage state. So this has to do with what are we extracting from the conversations, so that we can be able to maintain the working memory, maintain the short-term memory, and also maintain and preserve the long-term memory. If you are dealing with a customer that has allergies, that's something that you have to make sure that you are storing in the long term, so that in future conversations and interactions with the agent, you're not asking for this information brand new. You already understand the customer profile. You understand how many people are going to be involved, their billing address, their shipping address, their allergies, and things like that. So there are certain things that have to be in working memory. There are certain things that have to be in short-term memory. There are certain things that have to be in long-term memory. And there are different retrieval and memory strategies that we are going to consider in upcoming videos. So this is something that you have to pay attention to, because it does affect the context of the agent and what the agent needs to properly function and perform the task. So depending on the memory, you can see how this influences what tools the agent needs to call. So all of these things are all interconnected, but this aspect is very important, and you don't have to, you should not neglect it when you are designing your agent. The next thing we want to talk about is the large language model selection. This goes back to the user experience. If we have an agent that requires audio input, an audio output, or speech-to-speech interaction, then you have to pick a language model that supports that scenario. If you have an agent that requires audio analysis or image analysis, then you have to pick a language model that supports that. Depending on the context window and the reasoning ability, you may also have to pick certain large language models that will support this scenario. So going back to the user experience, that really drives the type of components that we bring into the architecture, and the LLM selection is one aspect of this. You have to pay attention to the performance, the budget cost, the latency requirements, and the quality of output expectation. So all of these things powered by or controlled by the user experience really determine what set of language models you're going to have to bring into the agent setup to support your scenario and your outcomes for the user experience. So you can really see how the user experience really controls everything. So when I started by saying that this is very important, it is very, very important. I want to talk about multi-agent collaboration and orchestration. So there are going to be times where setting up a single agent alone is not sufficient to do the job. So you have to think about how to set up the supervisor or orchestrator agent, and then break up the different segments of tasks into sub-agents or specialist agents, where the orchestrator agents would route the request to each of those agents depending on what you have to do. And this can also be a good idea because it allows you to set up specialized system instructions for each of the sub-agents without dumping everything into one agent and make it distracted with too many confusing instructions. It also allows you to set up tools for the specialist agent or for the sub-agent, so that you don't put all the tools in one single agent and also make it very distracted and confused. So if you have a scenario where you're seeing yourself having to write too many system instructions, too many tools bundled into the same agent, then you might want to break up the task into different segments, where you have a specialist with a limited set of system instruction and a limited set of tools that are handling that particular part of the request needed to solve the overall objective that you're trying to accomplish. So in this scenario, if we have agents that are part of the same process, you can use the workflows or some of the multi-agent collaboration strategies that are available in your framework, like PydanticAI, like LangGraph, or like Microsoft Agent Framework. But if your agents are not in the same process and they are across the network, then you should think about using protocols like agent-to-agent protocol to collaborate between these agents. So that is what I wanted to talk about here. I will have different videos where I will talk about multi-agent collaboration in the two scenarios where in one example you have all of them in the same process and you're just routing from one object to another object. And then we're also going to talk about and demonstrate scenarios where you are talking about agents that are across the network, and we have to leverage the agent-to-agent protocol and use REST, use JSON RPC, or use gRPC to collaborate between these different agents. So I want to talk about reflection, validation, and evaluation. So there are going to be scenarios where the one sub-agent or the agent may have generated some output, but prior to sending that to the user, as part of the user experience, we validate and we verify what is about to be presented. And if it's not correct, then you can have another sub-agent or a different agent to work on the task again, and then we compare the output until we have the desired outcome. So that's something that is very, very important. And then also over time, you want to verify the performance of your agent against specific benchmarks. So this is very important because if you are having a user experience that is not optimal, then you may want to tweak certain things in your model or your agent so that you can achieve the desired outcome. So allowing the agents to check their work before presenting it to the user is important, but also over time, we want to take a look at the different aspects of the system and then make sure that it is in alignment with what the original objective was. So that is where evaluation comes in, and the validation and reflection is also very important in order for us to give optimal outcomes to the customer. Now, tracing, observability, and diagnostics. In this kind of systems where it is stochastic and probabilistic, it's very important for us to make sure that we can keep track of what is happening in the application. So using tools like application insights and different logging mechanisms can allow you to keep track of the token consumption, what prompts are being sent, what is being passed around, and all those different things. If you don't have this in place, it's going to become a very challenging task for you to manage all of these systems. So you have to make sure that we can use instrumentation to keep track of everything that the agent is receiving, everything that the agent is generating, particularly in the development stage and also in production. This cannot be overstated. So keeping track of everything that is happening and what is going on inside your application will allow you to monitor and see what is going on, where things are going well, what is going not so well, and how you can optimize and improve it. Without this information, you're going to be flying blind, and it's going to be very challenging for you to figure out what to do when things go wrong or when you need to improve them. Keeping track of all of these things will also allow you to see where things are fast, where things are slow, where things are more expensive, or where you can use a less expensive option to accomplish the same or even better results. So keeping track of all of these things allows you to optimize for performance, optimize for cost, increase the margins if you're running this as a business, and also to keep the cost down. So observability is really important because without that, we cannot do this. And you see why they are all connected. And then making sure that we can reliably run each of the different systems. So design for the agent to have the ability to try again if needed, to handle timeouts gracefully, to make sure that certain operations can be tried again and again without any kind of side effects, making sure that they are idempotent, and then also making sure that when things come up, you're able to handle it effectively. So error handling, exception handling, idempotency design, graceful degradation, handling timeouts and fallbacks. All of these things are very, very important when you are designing your agentic systems. And lastly, When all of this is done, we have to have a process in place where things are checked into version control, where we're using CI/CD and DevOps pipelines to deploy the different components of this, deploying the architecture. If you're doing deployment on Kubernetes, if you're doing deployment on Azure Container Apps, if you're doing deployment on Azure Functions, what are you using to manage this? How are you configuring your managed identity, your system identity? How are you configuring the access controls? All of these things are very, very important to properly manage the lifecycle of the different agents, to manage how the agents are maintained and deployed, and all of those things. So this cannot be overstated or understated. You have to consider this, all of these things when you're designing. So let's quickly run through all the different 15 things that we talked about in this video. In a future video, I will do one video per topic, and I will do a deep dive into each of these, and feel free to post any questions that you have about any of these different segments that I mentioned today. So in terms of order of consideration, we started with the user experience, and we talked about why this is very important. And if you get this wrong, then you're most likely to get everything else wrong. So user experience controls the language model selection, controls whether it's going to be a single architect, single agent, or a multi-agent scenario. It also controls the tool calling that you need, how the system prompts are going to be configured, and all of those things. So without a user experience, you're going to get everything wrong if you're not doing that. Once that is done, then we can go into governance, risk and compliance, and then security, privacy, and identity management. And then you think about what you're able to tolerate without a human involvement. So think about what needs to be escalated to humans and what the agent can run by its own without input from a human. Making sure that the data pipeline is set up so that you can have good quality data for your agents to make decisions. How to manage the context is very, very important, and we're going to do a deep dive video on that. The tool safety and the tool calling architecture is very important, making sure that if you have tools that are going to be used across multiple agents, there's no need to replicate that logic in multiple places. You can just set up an MCP service and then use that tool in all the different places through MCP. Managing the memory is very important. So knowing what to bring into working memory, knowing what to keep in short-term memory and long-term memory is going to be very important. And what data stores are you going to use to manage those states and memory. The large language model selection, we talked about that. We talked about the multi-agent collaboration and when you need to do this to improve the experience. So that's very, 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 very important as to why we need to do that. If you have an agent that is going to be dealing with too many tools or too many conflicting system instructions, it's always best to split those up. And the strategy that you're going to use would depend on whether the agent is in the same process or in a different process. So if it is in the same process, all these frameworks like Pydantic, LangGraph, or Agent Framework from Microsoft have different workflows to manage the multi-agent collaboration in the same process. But when it is not in the same process, you have to interact across the network. Then the agent-to-agent protocol allows you to do that using gRPC, JSON RPC, or REST APIs to do that. And then reflection and validation is important for us to verify what we're going to send to the user before we send it. And if we have to fix it before we do that, we can keep going in the loop until everything is ready for us to share with the user. And making sure that you verify how your agent is performing over time through evaluation is critical. Monitoring everything that is going on would allow you to diagnose problems and optimize and fine-tune the operation and the business to make sure that you're staying within the right margins that you're expecting your business to be profitable. Making sure that you handle errors accordingly, and exceptions should not be allowed to bubble up. So make sure that things like that are trapped and handled appropriately. And then finally, making sure that you have the right strategy in place for version control, for CI/CD pipeline, and for deployment of these resources to the different infrastructure that are needed to support it. So things like database schema should be tracked and versioned. Any kind of schema, any kind of code, any of those resources that needs to be deployed has to be tracked and managed through version control, so that you can implement CI/CD pipelines effectively. So that's what we're going to be covering in this video. In a future video, we're going to do a deep dive into just one of the different aspects. And if you have any questions about this, please put it in the comments, and I would do a deep dive into that question as I'm addressing each of the different 15 areas. I thank you very much for your time, and I will see you in the next video.